name is Nick. I'm a front-end engineer at Livefront, and across all of our products, we write a lot of unit tests. Recently, I've had the chance to take a step back, think about those unit tests, and what could be better about them. How going forward can we write more efficient unit tests? On a zoomed out view, let's think about what is a unit test. Here in my example, I have a simple add function that takes two numbers and returns the sum. Below that, you can see I have the unit tests that go along with them. I'm testing positive numbers, negative numbers, and zero, and then expecting the correct result. And what about that makes it a good unit test? It demonstrates the code intent. Looking at the unit test, you should be able to give a little bit of information about what that method does without even looking at the definition. It can break when that logic changes. Breaking when that logic changes gives a good indication to a developer that either they need to update the tests or something they did in their changes is incorrect. And it isolates a single use case. If you have a class for say and have 8 to 10 methods in it and you're testing a handful of them at a time, if one of your tests breaks, it's going to be really difficult to go through all 5 to 10 of those methods and figure out where it's breaking, why it's breaking, and then make the correct changes. If you're testing them individually, it's going to be really easy to figure out either your test is incorrect, expecting the wrong output, or you need to go change the logic because you're not getting what you should out of your test. It prioritizes user interaction over coverage. Code coverage is a very hot topic, and people like to talk about the 80% to 90% to hitting 100% code coverage across their product. And it's a good method to measure up where your testing is, but it also leaves out how your user interacts with that code. If your tests interact with your code differently than the user does, there's a gap there that could be found in production, in QA, that you could have found in the development level. It improves developer experience. If you want to go into a code base and make refactoring changes or make additions to the architecture, the unit test should be there to solidify those changes and let you know that you made the proper implementation and also didn't break something that was already existing. Looking forward, I'd like to go through a little demo here about some unit tests and some downfalls and how we could go about finding and skipping those incorrect implementations. Here on the right, we have a grocery list app. It's simple to add an item here. We can add cheese, for instance. We can then mark an item as complete, or we could remove an item in general. Very simple app constructed with Angular here. On my left-hand side, you can see my add item component, which Angular has a class template structure. And the template here renders to the screen, and my class runs the data behind it. When I click the add button here, this add item method gets called. And if there is no item, nothing happens. And if it does, it interacts with this grocery list service here and adds the item to the list. This grocery list service is an Angular kind of syntax for state management. In React, you could be having a hook or Redux or another state management tool, even in Angular. Jumping into the unit test for it, here I have my isolated add item test. It tests that it adds an item using the grocery list service. It resets the form value, so then I'm not also seeing the value I already entered. And it doesn't call the service if there is an empty value. This is a great unit test to start out with, simple, but there is a downside here. If I go ahead and maybe make a drastic mistake of deleting the entire template and go ahead and save that, you'll see that my UI has changed. My tests have not changed at all, but I can go and look at my coverage. We'll refresh here, and I still have 100% coverage on my entire code base, which is incorrect because our UI is now broken, but we're not catching it in our tests. Let's go back and we'll do a little magic here of commenting out these bad tests that interact with the class directly. And we'll uncomment these ones that interact with the UI as we'd like to, just to simulate how the user does. We'll focus on this adds item using the grocery list. Here you can see I'm finding the input. I'm setting the value to cake in this instance. We're going to add cake to our grocery list. I'm then going down here and finding my button in the template, and I'm clicking on that button to simulate the user click. Saving these tests will then rerun my tests in the background. I'll be able to come over here and refresh my coverage file, and you can see now my coverage for adding component is now broken. And that's because in my HTML, I have no grocery list item to input or an add button for it. This is great. We caught our bug. So let's go back. We'll bring our form back. We'll look at our add items here. And now you can see that my input will be set to cake. I'll click on my button and we'll make sure our grocery list was called with cake as we would expect it to. We'll go back here, we'll refresh, and we can see we're back to 100%. So this is just a simple way to demonstrate that I've isolated my method. I've interacted with the UI as shown as the user would on this page. And now my unit test also demonstrates that, which is an awesome way to think about testing, should make testing easier going forward and make your unit tests overall better. Thank you.